So just as a refresher of where we were yesterday, is we were taking these angles, which is either a 15-degree angle, in this case it's a 15-degree angle, and I'm breaking it up into angles that I know that have a sum or a difference of that 15 degrees. So yesterday what we did was we said this is equal to the cosine of, and whether you use the 60 and 45 or the 30 and the 45, it would not have mattered. We chose to do the 45 degrees minus the 30 degrees. And then from there, we use the sum and difference for cosine. So we're going to continue with that today. So go ahead and work on C and D using the sum and difference for cosine or sine, or in this case, tangent. So if you don't have your unit circle, please consider getting your unit circle out. And when you're thinking about tangent, remember the angles that you know when you're going to do D. The angles that you know are the pi over 6, the pi over 3, pi over 4, and pi over 2. And in the other quadrants, the multiples of those in the other quadrants. So those are the angles that you do know. So you're going to use those or multiples of those to break up 17 pi over 12 into angles that we do know. So 45 and 30, so I'm going to write this as the cosine of 45 degrees plus 30 degrees. Because the 45 and 30 end up being 75. So now I'm going to use the rule that I have for the sum and difference. If I have the cosine of alpha plus beta, this is going to be equal to the cosine of alpha, cosine of beta, and with the sum and difference, if this is a plus, then this will be a minus, because they're always the opposite signs for cosine. And so I'll have the cosine alpha, cosine beta, and then the sine alpha, the sine beta. This is alpha, this is beta. So this is going to be equal to the cosine of 45 degrees, the cosine of 30 degrees, minus the sine of 45 degrees, the cosine of 30 degrees. And then I go to my unit circle, and I'm going to look for the values for the cosine of 30 and the cosine of 45, and the same with the sine. So this is going to be equal to the cosine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. The sine of 45 degrees is the square root of 2 over 2. And then the cosine of 30, or excuse me, that should be the sine there. Let me erase that. That should be sine. The sine of 30 degrees is 1/2. So my final answer, when it asks for exact, you have to write it in exact. And it's on the test where you have to write it as exact. So yes, I know you all have calculators, but you also get the unit circle, so do this in exact. And I'm going to do the square root of 6, because the square root of 2 times the square root of 3 is the square root of 6. And then minus the square root of 2, and because they're both over 4, I'm going to put the entire thing over 4. And there's your final answer. How was that? Questions, comments, concerns? Anything? Yes?
How can they subtract, like you got cosine 45, cosine 30 minus sine 45, sine 30?
So the question is, why is it the opposite sign? Well, that's because that's how it's defined up here. So if this up here, if this is on the cosine, if this is a plus, then this is the opposite sign.
Oh, okay.
It's always the opposite sign for cosine. Yes. Yeah, so they're always the opposite sign. Sines are exactly what you see. So it's a sum of sines, then it's going to be a sum when you break it apart.
Okay.
But cosine is always the opposite.
Okay, so
Any other questions on that one? Okay. So let's take a look at the second one then. So when I'm doing the tangent of 17 pi over 12, remember the values that I can use, I'll do this over here, is pi over 6, pi over 4, pi over 3, and pi over 2. Now I need to have the same common denominator to be able to add or subtract these. So I'm going to bump them up to 12 because that's what I see right here, is I see a 12 there. So I'm going to bump them up to 12. And so my first one becomes, instead of pi over 6, it's going to be 2 pi over 6. And then the next one is going to be 3 pi over 12, 2 pi over 12, 12. The next one is going to be 3 pi over 12, and then 4 pi over 12, and the last one is 6 pi over 12. Okay? How is that? How are we doing so far? Now remember, I can use any of these multiples to add up to 17. As I look and I got 2, 3, 4, and 6, is that going to give me 17? No. So if I go into another quadrant, and so my next quadrant, I'm going to have, my first angle I'm going to use is 3 pi over 4, that's one of them. 5 pi over 6, that's another one. And then what's another one in there? 2 pi over 3. Now let's do the same thing. Let's bump these up to denominators of 12 so that we can actually do the addition or subtraction. And so on the first one, I have 9 pi over 12. On the next one, I'm going to have 10 pi over 12. And then on my next one, I'm going to get, 8 pi over 12? Now, looking at my angles in blue, can I get any combination of those angles in blue that are going to add up to or have a difference of 17? Which ones do you all want me to use? So the 9 pi over 12? What else? 8 pi over 12. Okay? So the 9 pi over 12 is really 3 pi over 4. So when I come over here, I'm going to write this as the tangent of 3 pi over 4. Because it really is 3 pi over 4 before I bumped it up to have the same common denominator. And then it's 2 pi over 3 for the 8 pi over 12. Okay? Now I'm going to use the identity, the tangent of alpha plus beta is equal to, and it is the tangent of alpha plus the tangent of beta divided by 1 minus the tangent alpha tangent beta. Now confirm that's correct because I'm doing this off the top of my head. Is that correct? Okay. So then I'm going to go ahead and put those values in, and so I have the tangent of alpha, which is 3 pi over 4, minus the tangent of beta, which is 2 pi over 3, divided by 1 minus the tangent of 3 pi over 4, the tangent of 2 pi over 3. Yes?
Is this the same situation as the cosine formula? If it's a plus at the beginning, it's going to be negative on top.
So if it's, oh, sorry, that should be a plus. So it's, the negative is actually in the denominator. So the only place that you're going to see the opposite sign is the denominator. So if this is a plus, in the numerator it'll be a plus, but in the denominator it's a minus. All right, so now I'm going to get my unit circle out. And the tangent is the y value over the x value. We like 45s because those are always 1 or negative 1. Depends on where we are. So the tangent of 3 pi over 4 is going to be negative 1. And then the tangent of 2 pi over 3, I think, is the square root of 3. Confirm that for me. Square root of 3? It's the 60, so I think it's the square root of 3. And then over 1 minus a negative 1 square root of 3. So I end up with negative 1 plus the square root of 3 over 1 plus the square root of 3. And no, this does not cancel. The reason this does not cancel is because in the denominator I have 1 plus, and in the numerator I have a negative 1 plus, so those do not cancel. What you can do if you have nothing better to do is you can do the conjugate of the denominator if you're inclined. Remember, I'm never going to ask you to do that in this class. So if you want to do the conjugate, you can, but I'm not going to. And I'm not going to ask you to. If you don't want to do it, you don't have to. Yes?
When you're
angles to use? Do they have to do what? No, no. I could have used any combination provided that they have a difference of 17 or add up to 17. Yeah. So it doesn't matter which quadrants I use as long as that adder's addition or subtraction is 17 over 12. Yes.
I'm a little confused on where you get the tangent values in the unit circle, like the negative, the square root of 3.
Okay, so the question was, how do I get the tangent values? Well, let's just talk a minute about that then. So the tangent of my angle is my y value over my x value. So I go to my unit circle, and I'm looking for the multiples of pi over 3. Oh, and those should have been opposite signs. Those should have been opposite signs. Those should have been negatives. But there, we'll go back to it. Anyways, answering your question. I'll go back to answering your question. If I look at, say, the 60, what is the y value for the 60 in the unit circle? So the square root of 3 over 2. What is the y or the x value for the 60? So what I really have then is I have the square root of 3 over 2 multiplied by the reciprocal of the denominator fraction, which is 2 over 1, and that's what's the square root of 3. But I forgot the quadrant here, so I do have to go back. I apologize. The quadrant is in the quadrant 2, so that should be a negative square root of 3, not a positive. So let me go back and change that. So this should be a negative here because of the quadrant. And that makes this a negative here as well. And also, that makes this a negative here. A negative, negative. And so it'll end up just staying negative in the denominator as well. So I'm glad you asked that question because I would have just blown right through that and some of you would like, what? Okay, so don't forget where you're standing, whether or not it's positive or negative. How is that? Is that okay? Doing okay? Checking in? All right. Here we go.
Sorry, I have another question.
Oh, absolutely.
Is it does it have to be just two angles cosine and it can only apply the beta?
Yes, at this point it is. Yes. But so the question is, can you use more than two? Well, you could, but you don't want to. And what I mean by that is if you decide that you wanted to use 3 angles, which is okay, it's just you're going to have to do more work. So let's just do a quick example of that, and this is why I wouldn't do it. So let's just do cosine because it's easier than tangent. So I have to have the cosine of pi over 2 plus pi over 4 plus pi over 3 as an example, right? Then you're going to treat these two as beta. And so what you would write is the cosine of pi over 2 times the cosine of pi over 4 plus pi over 3. And then it'd be minus the sine of pi over 2, the sine of pi over 4 plus pi over 3. And then you'd have to do the sum and difference again. And that's why we try not to do that. You can do it, we just try not to do that. Does that answer your question? Yeah. Okay. All right, anything else on these? And why you prefer to stay with 2 instead of 3 or 4 or 5 angles? Okay. So go ahead and simplify these expressions as far as you possibly can. Now in this one, you're going to be looking at sums and differences. Look at pattern recognition, which is why we start out with the sequences and series. So you're looking for pattern recognition. What do you see? Do you see cos, cos, sine, sine? Cos, cos, sine, sine. So it's probably going to be the sum of cosine. So if I see cos, cos, sine, sine, it's either sum or difference of cosine. And then I look to see if the angles match. So this is pattern recognition. On the second one, you want to deal with the fact that you have the negative angles, so we have the odd and even stuff coming into play. I do want to say really quickly, though, because you may need to use this as well. If you have the cosine of 30 degrees, what is that equivalent to in terms of sine? So this is equal to the sine of what? If you look on your unit circle, the sine of 30 degrees equals to the sine of what angle? 60 degrees. So you can use that information as well. If those two angles add up to 90, you can replace them out. So if these two angles here, if this sum is 90, then you can use that any time. If you see the cosine of 10 degrees, you can replace it with a sine of 80 degrees. As long as those two add up to 90, you can do that every time. The cosine of 5 degrees is equal to the sine of what? 85 degrees. As long as those angles add up to 90, you can do that replacement. Yes?
What if there's after 90 on both sides of the equation?
We're not into equations yet, and we don't want to go there yet.
No. Like in this situation, if there's two 90s on both sides.
Oh, that won't happen, because these two angles here, these angles have to add up to 90. I can't have 90 on both sides because that adds up to 180. I think that's what you're asking me.
Well, the very first question, both sides add up to 90.
Okay. But do you see cosine, cosine, sine, sine? So it's probably the sum or difference of cosine. So then you ask yourself, does this angle match this angle? Does this angle match this angle? So if those two match, so it looks like this looks like the cosine of alpha cosine beta plus the sine alpha sine beta. That's what it looks like because my angles match. So what do you think this is going to combine into then? It's going to be the cosine of 23 minus 67. 23 minus 67. What is 23 minus 67 then? Negative 44? So this is equal to the cosine of negative 44, but cosine is what, odd or even? Even. So this is equal to the cosine of 44 degrees. How is that? Do you have any questions on that one? Yes? It's always, for cosine, it's always the opposite sign. So the question was, how come we're not adding them when we're subtracting? And that's because for cosine, if this is a plus between the two terms, then you are actually subtracting your angles. It's always the opposite sign. How is that? Okay, so please do B, C, D, and E. When I do B, the first thing I'm going to deal with is the odd and even on the sine and cosine that we learned from yesterday. So I know that this cosine is even. So the cosine of negative 80 degrees is just the cosine of 80 degrees. And then the sine of negative 20 degrees, that negative will pull through. So I'm going to rewrite this as the cosine of 10 degrees, cosine of 20 degrees. And that's going to be a minus. And the reason it's going to be a minus again is because of this. That negative on that angle makes it a negative sign. So a negative sign times a positive cosine, pull that negative through, so it's going to come out front. And so I have the cosine of 80 degrees, the sine of 20 degrees. Pattern recognition, this doesn't fall into what I want. It's not sine, sine, cosine, cosine, or cosine, cosine, sine, sine, or sine, cosine, sine, cosine. It doesn't fall into that pattern. However, I can use this information over here that we talked about right before we worked on these, is that as long as my angles add up to 90, I can switch out sine and cosine. So if you decided that to you this looked like the law of sines, which is fine, not the law of sines, but the sum of sines and differences of sines, then you would have replaced this one with the sine of 80 degrees. If you decided this looks more like the sum of difference for cosine, that's cool too, then you would have replaced this one with the sine of 10 degrees. Either way, you're going to get the same answer. How many of you guys said this looks like the sum of difference for cosine? How many of you said this looks like the sum of difference for sine? Okay? So for those who thought this looked like sine, we're still going to get the same answer, and I'm going to do the law of sines. So I'm going to replace out this with the fact that I know as long as the angles add to 90, I can switch out the sine and cosine. So I'm going to replace that with the sine of 80 degrees. Yes? Isn't 10 plus 80, 90? Yes. Good question, though, because if you're having that question, other people are as well. So what I've seen is that I had the 20s here. I had the 20s on both of those, so I'm going to ignore those. The ones that I needed to align are the 10 and the 80. Those are the ones I needed to worry about. They didn't align to anything, so I left the 20s alone, and I'm just working with the 10 and the 80. Yeah, good question. And so I'm going to rewrite this as the sine of 80 degrees cosine of 20 degrees minus the cosine of 80 degrees, the sine of 20 degrees. And now I've got sine, cosine, cosine, sine, which means this is the difference of sines. Now, if you did it with the other way, you're going to get the exact same answer, so don't erase what you have. You're going to get the exact same answer. So this is going to be equal to the sine of 80 degrees minus 20 degrees, which is the sine of 60 degrees, which is a square root of 3 over 2. So that is my actual final answer. Now, if you all decided that it looked to you like the sum and difference of cosines, you would have got to the end and asked to find the sine or the cosine of 30 degrees. So if that looked to you like the law of or the sum and difference of cosines, then you would have got down to something that looked like this. You would have had this equal to the cosine of 30 degrees, which is still equal to the square root of 3 over 2. So if you've seen it as a sum and difference of cosines, or you've seen it as a sum and difference of sines, you get the same answer. Which also shows you, notice that 60 and 30 add up to 90, and that's how I'm allowed to do that replacement, because they are the same value. How was that? Is that okay? Doing okay? All right. So this one we assume is radians. On C, we assume the radians, 5 and 6 radians. Does this have any pattern recognition here? Yes. What does this look like? So the sum and difference of cosines. So I have the cosine, sine, sine, and this 5 matches this 5, and this 6 matches this 6. So it is straightforward, the sum and difference for cosine. So this is going to be equal to the cosine of 5, and is it plus 6 or minus 6? You guys are rock stars. Awesome. So it's a cosine of 11, and we assume radians. How are we doing? Does it equal negative 1? I don't know if it, I don't think it does it equal negative 1? 11 pi over? Oh, no, because there's no pi attached to it. The pi is embedded into it. So if you put that, the question was, doesn't that just equal 1? Well, it does if it was pi attached to it, but it's not, it's embedded in there. So if you put in your calculator just in your radians, the cosine of 11, it's not going to be 1, it's going to be 0.9, yeah. It's not going to be 1. It'll be slightly less than 1.
So what's the difference between just a radian and like if pi is there, it's embedded?
So the question was, what's the difference between radians and when the pi is there? When I see 11 radians, this is not equal to 11 pi radians. Because 11 pi, oh, that's a really bad looking 11. 11 pi, that still isn't very pretty. 11 pi is slightly different than the 11 radians, because when I see 11 radians, I already have the pi multiplied in there, and I got an answer out of 11. So when I see 11 radians, that means I had some number A, I multiplied it by pi, and I got 11. So if I want to know what that A number was, is I'd take 11 and divide it by pi, which is not going to be a nice number. So that's the difference. But if I see 11 pi, that means I'm just looking for rotations, and I'll pull off rotations, coterminal angles at that point. All right, what about D? Do we see any pattern recognition here? Yep, what do we see? I see cosine, 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 sine, sine. This angle matches this angle. This angle matches this angle. So what is this? Sum and difference of cosines. And so I'm going to write this as the cosine of 3y plus or minus. So my final answer is the cosine of 4y. How are we doing? Doing okay? These are on the test, on the next test. These are, I pull them exactly verbatim off of this section. No, only one or two. Only one or two. Oh, we might have an application problem. We'll see what happens. All right, the next one. Do I see any pattern recognition here? The sum and difference of tangent. And I'm looking for this angle in the numerator. I need it in the denominator. This angle in the numerator, I need it also in the denominator as multipliers. So I see the sum and difference for tangent. And I look for the sign between them in the numerator to determine whether or not it is a plus or minus of those angles. So this is going to equal to the tangent of pi over 9 plus pi over 6. And now I need to actually do the addition of these. What's the lowest common denominator between 9 and 6? 18. So I have pi over 9 plus pi over 6. I'm going to multiply this numerator and denominator by 3, this by 2. So this will add up to, what is it, 5 pi over 18? My final answer is the tangent of 5 pi over 18. And that's as good as it gets without getting my calculator out. Yes? On B? Is, okay, the question is, how did I get actual values of 80 and 20? I actually didn't until I got to the sum and difference, when I brought this back together as a sum and difference. So are you okay with the fact that I ended up right here with a minus sign? Okay. And then are you okay with the fact that I replaced the cosine of 10 degrees with a sine of 80 degrees? Okay. So then once I've done that, it's pattern recognition. I have the cosine of 80, cosine, or sine of 80, cosine of 20, minus the cosine 80, sine 20. Because this is a minus between it, it is the minus of the angles between there. And so I ended up with 80 minus 20, which is 60. And that's one that I could do without a calculator. Does that answer your question? Okay.
Can you walk through E one more time?
Yes, absolutely. So on E, I am looking for, do I see the pi over 9 in two places? And I do. I see it in the numerator, I see plus, and then I also see the recognition in the denominator of pi over 9. So the pattern recognition that's happening here is this is the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha, the tangent of beta. And I see, I'm looking for the alpha here, here, and here, which I see in the blue there. I see the beta here, here, and here in the green in my example. So it is the sum and difference of tangents. Pattern recognition. So a lot of what these identities are going to be about when we get to them is pattern recognition. It's just recognizing we've seen this before, just in a different skin.
That's why it's no longer a fraction.
Yes. Yep. That's why it's no longer a fraction. All right. So now we're going to go on to these. Which one of these would you like me to do? One of them. I know one of them. Which one of these would you like me to do? The last one's always the hardest one. Okay. So when I come to this one, and these are on the test, and you're going to see them on your homework as well. The first thing you want to do is figure out where you're standing for each angle. They're giving me information about the cosine of alpha, so I'm going to work with alpha to begin with. So the cosine of alpha is equal to the square root of 3 over 2, or square root of 3 over 4. And alpha is in quadrant 1. So I need that information because I'm going to come over here and I'm going to work with alpha. So alpha, this is what I'm working with. I know the cosine of alpha is equal to the square root of 3 over 4. And I'm in quadrant 1. So because I'm in quadrant 1, that tells me all of my answers will be positive. I don't have to worry about remembering which one's negative and which one's positive. So I'm in quadrant 1, that tells me all my answers will be positive. The next thing I'm going to do is work x, y, and r. How do we define cosine? So this is x, this is r. When I am asked to find the tangent of alpha minus beta, the tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha, the tangent of beta. So I need to figure out what the tangent of alpha is with the information that's given to me. I have cosine. How do I find tangent? What am I missing to find tangent? Y. So I need to find y. What I know is x squared plus y squared is equal to r squared all day long. So that tells me that y is equal to plus or minus r squared minus x squared. We're in quadrant 1. Do I need the plus and minus on this one? No. So I'm going to erase the minus because I don't need it because I'm in quadrant 1. I just need the plus part. I'm going to put the information in that I know. So my information is the tangent, y is equal to the square root of 4 squared minus the square root of 3 squared. So this is going to be equal to the square root of 16 minus 3, the square root of 13. I am the prize. I need the tangent of alpha. So I found my y, and I need to find the tangent of alpha. So the tangent of alpha is equal to my square root of 13 over my x, which was the square root of 3. I'm just going to leave it like that for right now. So over here, what I have so far is I have the tangent of alpha. So in my equation here, where I see the tangent of alpha, I'm going to replace that with the square root of 13 over the square root of 3. Minus, I don't have the other one yet. And then 1 plus the square root of 13 divided by the square root of 3. That's what I know so far. I have replaced the tangent of alpha with the value I found off in the left-hand side. Now I'm going to do the same thing with my beta. I'm going to go to the other side. So my beta, I'm given the cosine again. I'm going to go over here and work beta. So now I'm going to do beta. I know the cosine of beta is equal to negative square root of 2 over 3. They also tell me I'm in quadrant 2. Quadrant 2. That tells me that both tangent and cosine are negative. So I'm expecting the tangent of beta to be negative. Okay? This is my x, this is my r, and what do I need? Y. So y is equal to the square root. I'm in quadrant 2. Is y going to be positive or negative? Quadrant 2. Quadrant 2. So I am positive because y is up. So y is positive, so I don't have to worry about that part. R squared minus x squared. So this is equal to 9 minus 2, which is equal to the square root of 7. The tangent of beta then is equal to the square root of 7 over the negative square root of 2. So I'm going to come back over here, and wherever I see the tangent of beta, I'm going to replace it with the negative square root of 7 over the square root of 2. There. And I'm going to do it here. Again, I'm replacing the tangent of beta with that value I just found, because that's what the tangent of beta is as a ratio.
Square root of 2 or square root of 2 over 3?
Square root of 7 over the square root of 2. So now, I'm going to finish this off, because I'm running out of time. So this is equal to the square root of 13 square root of 3 minus the square root of minus, so it's plus the square root of 7 square root of 2. 1 minus square root of 13 square root of 7 all over the square root of 6. What is my lowest common denominator? So I'm going to multiply everything by the square root of 6. I know I'm running out of time, and I apologize, and I appreciate your time here. So when I do that, my square root of 6 and square root of 3 reduce to the square root of 2, square root of 13, plus the square root of 3, square root of 7, over the square root of 6 minus square root of 13, square root of 7. And then you would actually do that multiplication, which I don't have time to do, but then you would actually do the multiplication through. And that would be your final answer. I will post this tonight at some point when I get home. Have a great day.